Hello and welcome to our presentation. Today, Nicole and I will be discussing Written in the Rocks, a chapter from Coyne's novel, Why Evolution is True. I, Allison, will be focusing on the first half of the chapter, while Nicole will be focusing on the second half. The topics I will be discussing include how is the fossil record constructed, what is radioactive dating, how are fossils formed, why is the fossil record incomplete, what is gradual change, and what are missing links. So, let's get started. First, how is the fossil record constructed? Rock layers, or strata, tell us about the relative ages of fossils. The relative age is the age of the rock layer in relation to other rock layers. Younger rock layers are on top, with the older rock layers below, due to the deposition of sediments. As you can see in this picture, there are multiple layers of rock, and at the top of the image is supposedly the youngest layer of rock. It is somewhat simple to use rock strata to classify time, but there is a better way. Radioactive dating allows scientists to analyze how old a rock is. Radioactive dating is based on the principle that radioactive species decay. Half of a radioactive species will decay in a given amount of time. This is called the half-life. Carbon is used to date younger specimens because of its shorter half-life, while uranium-235 is used to date older specimens. Sedimentary rock cannot be used for radioactive dating, but surrounding, harder rock can be. So now that we know how to date fossils, let's find out how fossils are formed. How are fossils formed? Well, step 1, an organism dies. Step 2, the organism's body is covered. The presence of water increases the likelihood of a fossil forming due to the quick sinking and covering of the body. Step 3, which you can see in the middle of the image, is that layers of sediment continue to cover the body. Minerals replace the material in the bones. Step 4 is that pressure turns the bones into rock. Step 5 is that erosion exposes the fossil. And step 6 is that someone finds the fossil. So, that was how a fossil is formed. But why is the fossil record so incomplete? Here are several reasons why fossils are hard to find. First, when an organism dies, other creatures may carry away its bones and remains, scattering them. This will make it much more difficult for anyone to find and piece together. Second, the movement of the Earth's plates, in which the crust is recycled slowly over time through subduction, means that very old fossils are destroyed by the lower molten layers. Third, the earliest organisms were soft-bodied, so it was more difficult for them to leave a trace. Something of note is that we have only discovered 0.1 to 1% of all fossil species. Despite the fossil record being incomplete, it does show us a few things. For instance, it shows us gradual change. Gradual evolution can be observed by taking a deep core of the ocean floor and observing the organisms within. For example, scientists have taken cores from the ocean floor and seen that plankton show a change in the number of whorls they have, which is the spins in their shell. And this happens slowly over time. An aside is that the ocean is where many fossils are formed, since they sink and are covered somewhat quickly. The fossil record, though incomplete, can show us something else as well. It can allow us to reason the appearance of missing links. Missing links should resemble something between two different species. For example, for the reptile to bird transition, the missing link should be a reptile with bird-like traits. Despite the incomplete fossil record, missing links can be reasoned and even eventually found. For example, the creature called Tiktaalik, who we learned about in class, had many traits that scientists reasoned would be present in the missing link between marine species and terrestrial quadrupeds.
Hi, my name is Nicole, and I will be presenting the second half of our presentation, Written in the Rocks. The topics I will be covering include the transition from fish to amphibians, the origin of birds, and the evolution of whales. Tiktaalik rosier, which Allison just mentioned as being a missing link for the transition of fish to amphibians, had features of both fish, such as gills, scales, and fins, and amphibian-like features, such as a flattened head with eyes and nostrils on the top instead of on the sides of the skull, and a neck. It was able to live in shallow water and breathe air. This fossil shows how fish evolved into land-dwelling amphibians. Now I will be talking about the origin of birds. Archaeopteryx lithographica, which is the first image on the bottom, is a transitional form of a reptile into a bird. It had features seen in reptiles, such as jaw with teeth, a long bony tail, claws, separate fingers on the wing, and a neck attached to the skull from behind, rather than below. Its bird-like features included large feathers and an opposable big toe. Another fossil of a reptile bird intermediate called Sinornithosaurus millenii, the second image, had thin feathers all over its body, while the Microraptor Gui, the third image, had 4 wings which were probably used for gliding. These theropod dinosaurs even behaved like birds, seen in fossils such as a female theropod nesting her eggs like birds, as the image below. There are several hypotheses as to how birds evolved due to natural selection. One is that feathers on their forelimbs help them glide from tree to tree or to the ground to escape predators and find food. Another is that they ran and flapped their wings, later combined with hopping, which is how natural selection favored flying. Now, I'll explain the evolution of whales. Whales are mammals that have a rudimentary pelvis and hind legs, suggesting their ancestors lived on land. Transition to whales included animals becoming more aquatic, nostrils moving farther back, and a reduction in the pelvis and hind limbs. In conclusion, the fossil record is a proof that evolution occurred. This is seen in rocks showing gradual changes in lineages, existence of transitional forms between different kinds of organisms, and transitional forms occurring where they are predicted to occur in the fossil record.